G'day, it's Tony Fortunato from the technology firm. I'm going to spend a little time showing you how I do things because that is a very popular question I get asked. I'll post an article or a webcast or something. People like the write-up, they like the results, and they always ask, how did you do that? So here we go. I've just done a write-up comparing 3 different trace TCP utilities or applications. One's a portable app kind of command line thing, the second one's more of a graphical thing, and the third one relies on cloud stuff. That's all going to be posted in another article. It's got nothing to do with this. The point is, one of the utilities, the command line one, trace TCP, I'm going to show you how I baselined it and what I found just to supplement the article. Alright, so let me know if you find this interesting, and I'll do more of these because, as I said, people keep asking me how do I do things, so I figured why not. This one's called trace TCP, as you can see, trace TCP right there, and I did it to google.com, and here's where it is. It's on GitHub, and on GitHub you'll see trace TCP. You can I'll put the link in the write-up as well, but you'll see that it's pretty easy to find, and you just download it. You just uncompress it or unzip it and just basically run it. Now, it does need WinP cap, so for everybody who uses Wireshark, you're covered, right? For the people who don't have Wireshark, you should have WinP cap, or this will not work properly. All right. Second thing is, you'll have to make sure you have administrator privileges. Most systems, some systems you don't need it, but just to be on the safe side, make sure you have that. So I got this. I ran this trace, and this will run a trace like a trace route, but it uses TCP instead of ICMP, and that's a big question people have been asking as well. How do I do a trace route if I can't use ICMP? It's being blocked, it's being rerouted, and that sort of thing. So that's why I looked into this trace TCP type tool. And you can see, off I go, trace route to TCP, trace route TCP to google.com, and off it went doing its trace route. Beautiful. So now let's get the trace file up. Now, this is an unfiltered trace file, so just a little trick. When you need to do these types of tests, ideally use a virtual machine, and then you can filter on its IP address, and that would be so easy. I did not do that. I'm using the worst case scenario. So I've got my machine doing all sorts of things. So what I did was quieted my machine down, shut down Outlook, shut down my web browser. I have everything shut down, so I just run this little utility so the noise is at a minimum. You're going to get a lot of extra stuff, but at least it's at a minimum. So in this case, we have 179 packets, right? So there it is. So the first thing you're going to probably do, because people like to do this, is they'll search for ICMP. Well, this is not using ICMP, but the error message it gets back is a time to live exceeded, which is an ICMP, which is right there. You see that? So if you wanted to try to filter on ICMP, right, you could do that, but I'm not seeing my actual trace packet because it's TCP based, right? So I need to know it's TCP based. I might not even know the port number. Well, in the actual ICMP packet, right, I've talked about this in other sessions, an ICMP, you actually have a copy of the header of the packet that caused the error. In this case, you'll see the IP, and you'll actually see the TCP information. So now I know it's TCP port 80. That's what I know because I didn't type that in here. You see, I just use the defaults. With trace TCP, you could use other port numbers, but the default is 80. So now I know. So now I should have a better filter than this, right? So I'm going to show you a little trick. Now up here, I'm going to just type TCP dot port equal, and I'm going to type 80. So now it's a display filter for just TCP port 80. And by doing that, you can see there's my TCP SYN, and there's the corresponding time to live exceeded. And again, if you look inside here, you'll find that there's the header, blah, 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 blah. If you ever want to make sure these two packets are the same, just compare this. In here, you'll see the IP header, and you'll see something called identification. That's what this is going to have over here, right? And those two identification values are going to be the same. Let me see, 5640, and let me just check down here. Internet Protocol 5640. See that? So that was in that packet as well, right? So now I know I can see the TCP, I can see the ICMP packets, and so on and so on and so on. Now, what's kind of interesting about this trace is if I want to just see these time to live exceeded packets, right? Again, I could just do an ICMP packet filter, right? I'm sorry, ICMP protocol filter. But a better way to do that, if I just select one of these time to live exceeded, I'm going to just stretch this guy up, the detail pane up, just for one moment here. I'm going to just kind of collapse these. I want to look at the ICMP protocol header. Open it up. Time to live exceeded. It's called type 11. Watch. Right click. Apply as a filter. Select it. By doing that, now I just see my time to live exceeded, and I can see the routers that are responding. So if I bring up the results here, right, I'm just going to kind of slide that over. You can see it says 10.44, 10.1, there it is. Then 129, there it is. 193, there it is. So now I can kind of just make sure that these equal these, as well as, you know, you do all sorts of things with it, but I just want to see how consistent this is because I did find something. So 34.6 is here, 34.6, and then this says 241, and if you look, there's 225, 241. See that? And only 2 came back, and that's what this was. This one did not come back, and there's one, and there's the other. But it just tells me about 241. It doesn't tell me about 225. So in this case, 2 routers came back, which is very, very realistic in the real world. You could have multiple routers, multiple paths, you know, load sharing, all that kind of nonsense, right? So this is kind of nice to know, but this tool didn't tell me that. So now I know. So in a nutshell, that's kind of it, right? So let me just go back here. I'm going to just do a simple TCP filter. And again, because I wasn't doing anything else, you'll see the TCP 8080, right, and that kind of thing. But just be careful because you could be talking to other things in the background. So the best thing to do is at TCP.port = 80, and then you could work from there. And then lastly, an ICMP filter for the time to live exceeded, so you can compare apples and oranges. So hope that helps. Have a good day. Bye for now.